So I want to jump right into lists in particular in Java. And so I think most of you are already familiar with lists in the form of the array list. I think you had a chance to use that when talking about arrays. So let's actually let's walk down that path when examining this collections framework. So let's start by just defining a list in Java. So a list in Java is a collection of storing elements in sequential order. And so sequential order means that the first element followed by the second element, followed by the third element, and so on. A good real-time example of a list is a line of train cars on a track. And to get the fourth car from the first, we'd have to go through the second and third in that order. So Java list is a sub-interface of the collection interface that is available in the Java util package. Sub-interface means it's an interface that extends another interface. And here the list interface extends the collection interface. So the general declaration of the list interface in Java would be something like this. We are going to create a public interface list. And here, this is our type parameter that allows us to assign a typing to our collection. You've probably seen this, but if you haven't, that's what the angle brackets mean. So, and whenever you see just the letter E, it just means it represents any element. It could be any type of element. So here we're creating an interface list that will extend the collection of that same type of element, which is generic because it could be anything. Okay, so it is an ordered collection where elements are maintained by index positions because it uses an index-based structure. In the list interface, the order is retained in which we add elements. We will also get the same sequence while retrieving elements. It is used to store a collection of elements where duplicate elements are allowed. List interface in Java has 4 concrete subclasses. That's ArrayList, that's LinkedList, that's Vector, and that's Stack. These 4 subclasses implement the list interface. So ArrayList and LinkedList are widely used in Java programs to create lists. Vector class has been deprecated since Java 5, and we're like on Java 17. So please do not use the vector class. It's listed because it exists, but typically you will either use ArrayList or LinkedList depending on whether you're constantly reading from the array or constantly reading into the list or writing from the list. That's going to determine which of those you should actually use. So some features of the list interface in Java. The list allows storing duplicate elements in Java. So the JVM differentiates duplicate elements by using index, right? So index refers to the position of a certain object in an array. It always starts at 0. So the JVM will differentiate between both elements in the list based on their numeral position. So that's why it allows for duplicate values, because each of the index values are always going to be unique. Therefore, the index is very useful and plays an important role to differentiate your objects. So in the list, we can add an element at any position. We can maintain insertion order. So lists can preserve your insertion order by using the index number. It allows for storing many null elements. So you can have, say, for instance, when we, just like an array, you can have like an empty cell inside of your collection so that you start your indexing at 1, for instance. Java list uses a resizable array for its implementation. Resizable means that we can either increase or decrease the size. Except for linked list, ArrayList, and Vector, it is an index-based structure. Oh, I think except for linked lists, ArrayList and Vector, yeah, it's an index-based structure, and it provides a special iterator called a list iterator that allows accessing the element in the forward direction using a hasNext and next method. In the reverse direction, it accesses elements using a hasPrevious and previous method, and then we can add, remove elements to the collection, and we can also replace the existing elements with the new element using the list iterator. So how do we create a list in Java? Well, to create a list in Java, we can use one of the 2 concrete subclasses, either ArrayList or LinkedList. And we use ArrayList to create a list, and test methods provided by the list. So here, for instance, would be an example of how we can instantiate a concrete form of an array list. And here we could bind it into a variable of data type list, which is the parent interface. And we could do the same thing, invoking linked list, doing the same thing, saving it as a data type list, same with vector, same with stack. All of these are concrete classes that we should be able to go ahead and utilize right out the box, provided to us right by the java.util. Okay, let's talk a little bit more about how to create a generic list object in Java, because after Java 5, generics were introduced. That allows us to restrict the type of object that can be stored in the list. So before Java 5, lists only held objects, which means that you could put anything in there, and that's super dangerous if you're expecting a particular type of data inside of a collection. And so to solve that problem, generics were created. And so it creates what's called a type parameter that can then be associated with a container type. So here, even though the data type is list, the parameter type, the type parameter that a list can contain would be string. And so we put that in angled brackets immediately after the declaration of this data type. So here, list string would hold a new array list of data type string. And notice with the primitive data types, we use the object type with uppercase because container classes have to be object-based. They can't hold primitive data types. We've already mentioned that before, but here, this is a good example of how we're using auto boxing and unboxing. And then starting with Java 7, it should be noted that you can just use the diamond operator during the instantiation. So this still works where you declare the data type like string or integer or whatever the object type is. But what's more commonly done conventionally is you only do the data type declaration on the declaration of the variable, but on the instantiation of the instance, you just leave that blank. And the open close angle brackets is what's called the diamond operator. Okay, list initialization. After creating a list, we need to initialize the list by adding elements to it. There are 3 methods to initialize the list. They are, you could either use arrays.asList, you could use the normal way, or you can use an anonymous inner class. So the Java list interface provides 10 specific and useful methods to the 15 methods specified by the collection that interface extends. So the list interface does 10 methods out of the 15 methods specified by the collection interface, which means only 5 of them are left ill-defined, that are left abstract. And so these methods are the add method. So it starts to add to a specified element from 0 location. And if the element is already present at 0 location, it will add to the next element in 1 position, right? So just like you'd expect to iterate and add iteratively in an array, that's how add's going to work. You also have the ability to have 2 parameters in add, where you can add based off of the index and the object you want to insert at that index. And this method adds the specified element at a particular position in the list. For example, if we want to add the element D at the 3rd position, we can call here list.add index 3, and then the value we want to add into it. We have the add all method that's defined for us here. The collection C represents a group of elements. This method is used to add or insert a group of elements at the end of the last element. So suppose that we had this list here where we add X, Y, and Z. And now suppose we want to create a list of another group of elements. So here we have list 1 with A, B, and C. Then on our original list, we can say add all, and then we can just pass this other list element we had, and it'll add the group of elements into our original list so that we will have X, Y, Z, and then A, B, C. So it allows us to merge two lists together. And then we also have add all, where we have two parameters where we can pass the index where we want to start inserting the contents of the given list here into the list we want to merge it into. And then for remove, it'll be used to remove an element at a particular position. And then again, return true or false. Another of the implemented methods inside of lists is the get, where you give an index and the method is used to return an element or object stored at that specific position. You have index of, where you can pass an object into the list and it will search and tell you what position number, what index of that value is. And if it's not inside of the list, it will return a -1 value to let you know that no value was, that object was not found. And then you can also use the last index. So this index of by default returns the first instance inside your list, whereas last index of will return the last occurrence of a specified element in the list. And again, if it's not in the list, it will return a -1, just to let you know that it was not found. For your set, you could set at a particular index, a given object will replace the existing element at the specified position. So unlike insert, where it will move all the elements from that position back, set will just overwrite whatever's at that current position. So just like you'd expect the method set, and just like what you'd expect the method get to do, it gets a value at a position or it overwrites a value at a position. And then list iterator returns a specific list iterator of the element. And so in the list of the proper sequence. And we can also even pass an integer value to return a list iterator at that index of our list. So we can start the list iterator at a specific point. And okay, so let's take some different kinds of example programs based off the above methods to understand better those 10 methods that are defined within lists out of the 15 defined in collection. So here, just an example program. We're going to import our array list from Java util. We're going to import our list from Java util. This is our interface. This here is our concrete class. We're going to create a public class, add example. Here we'll create a main method. Here we're going to create a new array list. And we won't bother using the generics on it, just to illustrate how we can just create a array list. That's not very safe in terms of type safety. Here we will add our integers, 10, 20, 30, 40. And then to illustrate how dangerous this is, in this format, without generics, we can add a string because it's just storing everything as objects. Then we'll add at position 435, we'll add at position 545, and then we can print it out. And then if we were to do that print out, the contents of our array would be 10, 20, 30, 40, then 35, 45, and then that string. So again, this is just a use case of how we would use array lists. And notice we can couple that using as data type list and still access many of these different methods that are critical because these are defined inside of lists. So it doesn't matter that we're using an abstract or interface type because all the methods we care about for managing our data are defined at that level. So we can treat our data in a very abstract space without having it specifically be an array list or a linked list. Okay, let's see. Just another quick example here. We'll import an array list. We'll import a list from java.util. We'll create a public class add all example. Here inside of our main method, we're going to create a new array list. Here we're actually using generic, so we're going to use a type parameter of string. Here we'll add some strings into our list. Our array list, so apple, mango, orange, and grapes. Then we'll go ahead and print that out. And then let's create a second array list of strings. And here we'll add the string 11, the string 12, and the string of 13. We'll print that out. And then we'll use the add all on our array list, our AL, to go ahead and insert an index to our AL2. And then we'll print out that value. And the expected output would be, well, we have our list 1, which would be apple, mango, orange, and grapes. We'd have our list 2, which would be 11, 12, and 13. And then after merging those, we would have the apple, mango, and then we did our insert at position 2. So that would be 11, 12, and 13 as strings. And then we would have orange and apples. So again, it just shows you the flexibility we can have with these collections and what we can do with them. So let's talk about the Java list versus an array list. So list is an interface, whereas array list is an implementation class that implements the list interface. So when do you want to use list? Well, there are 3 things you should consider and keep in mind. List can be used when we want to allow or store duplicate elements. It can be used when we want to store null elements, and when we want to preserve the insertion order, we should also use list. So these are the instances of when you should select to use a list over something like a set or a map. It all depends on, do you want to have duplicate elements and do you want to maintain insertion order?